Okay, well, welcome. I think we're going to go ahead and get started. It's 1:30, and we may have a couple more coming in, but thank you for making this Tuesday afternoon presentation. And my name's John Teravskis. I'm with WGR Southwest, and our office is out of Lodi, California. And I had the pleasure of being here, it's been maybe a month or two ago now, talking about post-construction standards. But today we're going to switch gears. We're going to talk about another requirement of this municipal permit that the City of Chico has to live under and has to implement. But this time we're going to be talking about during construction. And specifically, we're going to look at the topic of training small project proponents on how to prepare an erosion and sediment control plan. And so with that, I've divided it up into two parts. The first part, we're going to just spend a few moments looking at the permit requirements. What is the city required to do, and therefore what are they requiring the small project proponent to do? So just some basics about this. As I mentioned, the City of Chico has a stormwater permit. Just like many larger construction projects do, larger construction projects will fall under the State Water Board's construction general permit. The City of Chico also falls under a general permit, a general NPDES permit that controls the city's stormwater program. And there's many aspects of that, but today we're going to focus on the construction aspect. And so there's going to be a lot of acronyms, undoubtedly. And if I lose you in any acronyms, please stop me. I've even been known to say full sentences in acronyms. So if I've done that, I'm talking way too fast. So just slow me down. But the one right off the bat is MS4. It stands for Municipal Separate Stormwater Sewer System. It's basically the municipal drainage system, the municipal storm drainage system. And so we'll talk about an MS4 permit. That's the permit that the city has to operate under. So now this permit is not the same as another stormwater permit. In fact, they're both even general permits. By general, we mean kind of a one-size-fits-all permit. I guess the state used to write what's called individual permits, and they got tired of writing an individual permit for every project or every city, so they put together what they call a general permit, and this is where all parties fall under that. So in the construction industry, what we know about is typically that project that's over 1 acre of soil disturbance, they have to file a notice of intent, file for coverage under the construction general permit, and get coverage under that. So we're talking today about a different stormwater permit, and it does affect construction activities, but sometimes there can be some confusion. In fact, there's even some overlap. We'll even use very similar terms, and so I'll try to keep those separate for you. So both permits are issued and enforced by the State Water Resources Control Board, and both affect construction projects. But they affect them in different ways, and as we'll see. So let's do a side-by-side just to kind of keep our thinking clear about this permit, a side-by-side. You'll see the first column there is the construction general permit, and this next one is the phase 2 MS4 permit. So the oversight agency in this case, for the construction general permit for those large projects would be the State Water Board or the Regional Board. With the Phase 2 MS4 permit, the oversight agency is the City of Chico. And one of the reasons why this permit exists is that the Water Board is using the municipal permits to help them prevent pollutants from going into stormwater discharges or into receiving waters. And so basically through this permit, they're getting the assistance from different municipalities like the City of Chico to do some of that oversight activity. And so as far as what's required to be submitted, a compliance plan is required to be submitted by both permits. If you're under the construction general permit, it's that SWIP plan we've all come to know and recognize, that Stormwater Pollution Prevention Plan. However, we're going to see here in a moment that even very, very small projects under this municipal permit have to submit a similar document. Not exactly the same, but similar in intent anyways, and it's an Erosion Sediment Control Plan, ESCP, Erosion Sediment Control Plan. Now, legal authority. Under that construction general permit, the legal authority is the Clean Water Act. And the permit itself contains the regulations that construction proponents need to be complying with. And so if you're out of compliance, then you're going to come under the scrutiny of the State Water Board, and you might be leveraged fines that are under the Clean Water Act. However, the legal authority under the MS4 permit is really the municipal code. And that was one of the requirements under this permit, is that municipalities like the City of Chico develop ordinances, municipal code that gives them the legal authority to require these things, because the municipality has no legal authority to manage or to regulate the construction general permit. That's really only the State Water Board has that, but municipalities do not. So the Water Board, understanding this, when they wrote this municipal permit, said, okay, you're going to develop municipal code that requires that any project disturbing soils has to submit this erosion sediment control plan. It requires inspections. So speaking of inspections, that's the next row you see on the table behind me, is that under the construction general permit for those bigger projects, they may get inspected by the State Water Board. And from what we've noticed, that is not super frequent. Maybe 30-40% of the projects get inspected. Probably the larger the project, the more noticeable the project. If your project's located on the freeway on the way to work for the inspector, maybe your chances are greater. But they seem to be somewhat random or unpredictable. I'm sure they have a method to how they approach the frequencies, but you as the discharger or as the construction proponent, you really never know when you might get inspected. However, with this municipal permit, your inspections now are going to be quite regular. In fact, the permit requires the municipality to do a before a construction project starts inspection, basically a meet and greet with the project proponent saying, okay, here's your erosion sediment control plan that you submitted, here's what you agreed to, this is what we expect to see happen at the site. Then when construction starts, you'll be having these monthly inspections just to make sure that it's compliant with the city's municipal code and make sure that it's consistent with the erosion sediment control plan, that everything they said they would put into place is being put into place. And then there's the after construction inspection. So after construction's all been completed, the city inspector will come out one more time to make sure that final site stabilization has been achieved, that the threat of erosion has been mitigated through the development or the landscaping or whatever's been put into place. Pretty similar to the type of expectations you would have under the construction general permit. Now, applicable projects. This is where it gets quite different. So under the construction general permit, as I mentioned, it's that 1 acre or greater. Now there is a clause that says if you're a part of a larger common plan, so let's say like a big block store's going in, maybe a Costco, and on the corner they're putting maybe your favorite restaurant, I don't know, what is that, maybe, I don't know, Five Guys going out on the corner. And so that obviously is less than an acre, but it's part of the larger common plan. Therefore, the two projects need to have coverage by the construction general permit. However, the Phase 2 MS4 permit requires the municipality, so it's the State Water Board, same entity, but now they're talking to the municipality saying any project with any soil disturbance needs, one, to be on your inventory, you need to know about it, and two, you need to require an erosion sediment control plan, and then three, you're going to need to start inspecting these. And so any project that the city would know about, well, that would be anything that passes through the building permit process, grading permits, plan check, even their own capital improvement projects would need to be on their inventory, would need to have erosion and sediment control plans that we're going to talk about here, and need to be inspected once construction starts, or even that before construction. So erosion and sediment control plans, that's why we're here today. So let's focus in on that requirement. They're required of all projects with soil disturbance that are passing through the plan check or grading or building permit process, as I just said. Now, the permit does not specify any specific set format, and so we have developed a format with the City of Chico to basically come up with something that's a little more user-friendly. Not quite as user-friendly as we would have liked it to have been, because our hands were kind of tied with the regulations. There were certain things we had to require in it, but nonetheless it should be a little bit more user-friendly. The permit requires that the rationale be provided for the selection of BMPs and those BMPs you don't select. And that's why I said it wasn't quite as user-friendly as we wanted to, because the permit requires that we actually walk through this rationale, as you'll see here demonstrated in a moment. The required SWIP for those projects that are under the construction general permit may be submitted in lieu of an erosion and sediment control plan. Now, the thinking is that those larger projects over an acre, they had to develop this document, usually under certified individual, qualified SWIP developer, or QSD as they call them. And so they're usually at a much higher level of detail, and supporting calculations go into it. And so the city is going to accept those much thicker documents, usually they're 2 to 3 inches thick, in lieu of the erosion and sediment control plan, which you'll see here in a moment. And the city must have the submitted erosion and sediment control plan, or that SWIP, reviewed by a QSD, someone on their staff that's a QSD, or it could be a staff member who's working under the QSD that's been trained and is supervised by that person. All right, so that's kind of the background on why the city's requiring these things. And the bottom line is that's a permit requirement. The city does not have a choice, and in order to meet its permit requirements, it has to require these. So let's talk about preparing this document. And Rich Burgee and the staff asked that we really focus towards that smaller project. The thinking is that the larger projects, they're going to have to hire and utilize that qualified SWIP developer, QSD, and that person had to go through 3 days of training with the State Water Board through their program, and have obtained their certification. So, those sizes of projects are not going to have quite the challenges that the smaller ones who, when we say you need an erosion sediment control plan to a swimming pool contractor, they might go, oh, what? I've never seen one of those. So we're going to try in the rest of this presentation to demystify that a little bit. And so you should have in your hands a copy of this that you see behind me on the screen. This is a worksheet that we developed for small construction projects, and really this would be probably 80% of the erosion and sediment control plan submittal, in which they will identify their project, identify some just basic information about the project, like who is the owner, who's the contractor, the scheduling, sequencing, that type of thing. And then it walks them through the process of selecting best management practices, or BMPs as we call them. So that's what we're going to walk through. The rest of this talk is talking through that. And so on the second page, or second narrative page, you'll notice that we tried to give some background, again, that trying to achieve that user-friendly format to say, okay, here's what this document's all about, here's who's required to submit it, here's what's required with it. And so we really tried to break it down as best as we could for that small project person. I thought that the best way to demonstrate this would be to actually do an erosion and sediment control plan with you. And so we had some fun. We actually took a tour of the city, and we selected a site. So we're going to zoom in on that and see if we can find a vacant lot within the city of Chico. And you may or may not recognize it. Please don't tell me that something's already been built here. It'll ruin my whole presentation. But here's a lot that we found. We thought, okay, let's say they're going to do an infill project. A single family home is going to be built on this vacant parcel in a semi-residential neighborhood. And zooming in here, you can see that it's on 9th Street and Bartlett. So maybe after today's talk, you can go by. Does anybody own that piece of property? Okay, good. So here's our lot zoomed in a little bit, and I even have some photos courtesy of Google Earth. You can see what it looks like. So pretty much a small, simple site. Notice too in these photos, you'll need this for future reference, where the fences are at. What kind of fences? You notice that it looks like that's probably on the west side. There's chain link. The north side looks like a wood fence, partial fence on the east side. And so we're going to leverage all of that. All right, so what you'll probably want to do for this talk is use that worksheet to follow along. We're going to just basically work through this, and so we're going to be starting on page 5. Well, page 5 is just project information, as I had mentioned. Where is the project located? And in that you can give the project a name. It could be, just the Smith residence, or could be the owner's name, whatever, project address, and most of that is self-explanatory. Anticipated construction start date, that's important, although it may be a guesstimate at the time this is being submitted. And anticipated construction end date. Approximate soil disturbance, we want to know in either square feet or acres. And then also very, very important is, where are the municipal storm drains located in relationship to the site? We want to know, especially if they're within 50 feet of the site. Then we have just owner name information. Contractor, now it might be owner builder. It might not be that they've selected a contractor yet, so whatever's known at the time of the submittal. All right, now moving over to section 4 on page 7, this is where we get into our BMPs, our best management practices. So the first one we're going to address is run-on control BMPs. And we have a little blurb here that says, when surface flow of stormwater runoff is allowed to pass through disturbed soils at an active construction project, it can mobilize sediment and carry it into the municipality's storm drainage system and into the local receiving waters. This results in deposition of sediment in the municipal drainage system, which causes more frequent maintenance and can cause flooding. The sediment is also harmful to local waterways. So again, we're trying to take that user-friendly approach where we're trying to also provide a little reason why we're even concerned about this, why is run-on a problem, and then we give a bit of a graphic there of how they could deflect or divert run-on from coming into disturbed soil areas. So there's only 2 questions under this one. First one, does stormwater have the potential to run on to the construction site? And so we're going to look at this here in a moment, but really not much, as you're going to see. The site's pretty flat. Yes, there's a little bit, but it's really probably not going to be problematic. If yes, will stormwater surface flow be diverted around any disturbed soil area? So in our case, we picked no, but then in that case, it's querying them saying, okay, you're going to need to show how you're going to manage this run-on. So let's go to our project site and let's take a look at it. Now, when they're drawing the diagram of the site, the map of the site, it's very important that they include something that's quite obvious, at least in the requirement, but we see many maps that do not get submitted with this, is the boundary. We want to know the project boundary. in some instances, it's very obvious. In other instances, you're left guessing if you don't know a whole lot about the project on a first-hand basis. So we want to make sure that they show the project boundary. Now, also going off of Google Earth, I looked at the elevations, and that's not hugely scientific, but yeah, it's still a good indication of how the area will generally flow. And you see it's pretty flat, a little bit on the east side, 215, and so when we draw in our arrows, our flow arrows on the street, it's basically going to be flowing east to west, and on the side, generally east, maybe northeast, but probably it's going to be, especially with the fences that are there, probably going to be pretty much just sitting where it's at. In other words, we're not going to have a lot of significant run-on from offside. Not that we won't have any, but I don't think it's going to be an issue. And so this is that first section they want to look at. And then the other thing that needs to go on to the erosion sediment control plan map is the development. What is the development going to look like? Now, you're going to see at the end of this presentation that the building department wants to see these erosion sediment control plan notes and features put onto a set of plans. But especially for the small project that may not have an engineer, may not have something that's being designed through AutoCAD or an architecture, they may be just drawing out things by hand. There's various tools that can be used, and that's one of the reasons we put this together the way we did. Is Google Earth is an awesome tool. And so you could take the screen prints that were showing up here, lay it in with some very simple tools using Microsoft Word or PowerPoint as I used here, and show roughly here's where the new home is going to go, the driveway and sidewalk, the patio. We'll also show how things will be graded a little bit differently, to flow a little bit differently. Basically, the backyard's going to continue to flow to the west, and then both sides of side yards will drain forward towards the street, and the front yard will drain towards the street. So obviously, the street will continue flowing east to west. And so we show our project development, we show our boundary, and we show our post-development drainage patterns. And again, very important to show that on this erosion and sediment control plan. All right, now go to the next section, 4.2, erosion control BMPs. And here we give a definition of what is erosion control. And the definition of erosion, first off, is the detachment. That's keyword. It's when soil particles become detached, when they break free. So these particles can become detached by rain, wind, or construction activity. Through construction, although construction by nature disturbs soil, it is vital to place a temporary or permanent covering over disturbed soil as soon as possible. So we're recognizing that you're going to disturb it, otherwise it wouldn't be construction. We're going to face reality of the situation is soils will be disturbed. But as soon as possible, we want to put some sort of blanket over that to keep soils from becoming further disturbed by rain, wind, or further construction activity. Projects are not allowed to leave areas of exposed soil that do not have a cover. So no longer is it allowed by city ordinance and also by the state water board's regulations, no longer is it allowed to leave a site with just dirt, exposed dirt that was disturbed during construction. It's got to be stabilized in one way or another. On the table below and on the site map show how you will prevent erosion at your project. And so we're going to walk through some of these. Now, these are some options. It's not mandatory to select them all, or even necessarily to select any certain number of them. What is mandatory is that you do provide that effective soil cover as soon as possible. And so how this worksheet works is that you need to select the BMPs you're going to use, indicate which ones you're going to use, and then in the last column there, describe what you're implementing, maybe a little more detail on that, and if you're not using it, why. So let's go through the first one. All right, first one, EC1, scheduling. And in this case, for this project, we said yes, they're going to get the grading done before the bulk of the rainy season comes in. And so they're going to use scheduling to their benefit to get a lot of that soil disturbing work done early in the season before we get the rains. Now, is that mandatory? No. City ordinance is not saying you must grade during the dry season. You still can do grading during the wet season. But the point is, it's a good best management practice and something they should consider. And so if their schedule works out, or they can work it out so that they get that done early, or even the whole project done during the dry season, then great. That's a fantastic BMP. It'll probably save them a lot of other headaches that they may have. However, if your project is starting when most projects start, November 1st, and it just seems to be that's the way it goes, they're going to need to explain why. And it might be just because of the approvals, because of the mandatory schedule they're working under, whatever, the financing, the funding of the project, etc. It may be that they just had no option to start during the dry season. All right, next one is EC2. It's preservation of existing vegetation. Well, at this site we were looking at, and we'll take another peek at it in a moment, there wasn't a lot of existing vegetation that will be maintained. However, there were all those perimeter trees, and so much of those along the fence line, and some of them might have been on this side, on their property side. Some of them were probably on the neighbors, but those perimeter trees are going to remain in place. But other than that, it's a pretty small site. It was already pretty much a dirt lot. There wasn't too much existing vegetation to maintain. EC4, area to be vegetated with landscaping, turf, or hydroseeding. And well, yes, it's a small home that's being put in there, and before they're done, it will have permanent landscaping to be installed. Temporary erosion controls, this is EC7, using an erosion control blanket or geotextile. Will that be used? Now, I selected yes because we've seen for home building, many times home builders, and even some of the larger home builders, like to lay down a geotextile right alongside the front of the home, and sometimes along the high foot traffic areas, and use that for some stabilization of dirt areas, and it provides a little cleaner work environment. We elected to do that in this case. Do you have to do this? No, you don't have to do this. But again, as I mentioned, you do have to have erosion addressed one way or another. All right, so now we're talking EC6 and EC8, area covered with temporary or permanent mulch, including straw, wood, compost, hydromulch or equivalent. And in this case, we're going to select a temporary erosion control measure for the backyard and the front yard, and that's just broadcasting by hand some straw. Basically going to the feed store, getting 2-3 bales of straw, maybe 4 at the most, and broadcasting that out to give a blanket down on there. Now, we're not talking about blowing it by machine. It's much too small of a project to do something like that. And so we picked something that we've seen, in our opinion, to be very effective, both cost-wise, but also from erosion control. It's a very effective blanket. And then EC16, non-vegetative stabilization. Well, in this case, and you'll see in the diagram, we or the project proponent said, okay, we're going to go ahead and put in that driveway early on in the project. Same time the building slab's going to be poured, we're going to pour in that driveway. And that driveway is going to give a bit of a work surface to work off of for the contractor, basically pulling his truck after it's cured and ready to be worked off of, but would work off of that. Of course, they're going to need to be concerned about scarring it or damaging it, so that will be a limiting factor as well. And then finally, under erosion control is wind erosion. Now, on a small project like this, it would be probably, if you had a dust issue, it would be using just water to spray it down with a hose. Obviously, you don't have room for a water truck in this case. And once you get that straw down on the backyard and front yard, that's going to take care of a lot of it as well. So what would that look like on our plan? And up on the screen, show some of this. So we show how we're preserving the trees right here. And then we show in the backyard and front yard and even side yards, we show our straw. Again, this is just hand broadcasted out. We show our driveway and sidewalk that was installed early on in that project. And here's our geotextile just for high foot traffic, basically to provide a little bit of a cleaner surface to work on, a little less cumbersome than the straw, and also erosion protection, and even some of track out control, not by vehicles, but just by foot traffic and wheelbarrows and that type of thing. So it just provides a cleaner surface. Now, is any of that mandatory? No, none of that is mandatory per se, but the project proponent does need to demonstrate how they're going to keep soil particles from becoming detached by rain, wind, or construction activities. And so there's many different ways that a site like this could be approached. We tried to approach it in our concept here from what we think is a cost-effective approach, where even the homeowner themselves could do much of this. These geotextiles can be picked up at a construction material retailer like Whitecap or somebody like that, the straw from a local feed store. It's things that a small contractor or even an owner-builder could do themselves and not break the bank. All right, let's move on now to sediment controls, because we've only addressed erosion controls. And that's where we see a lot of confusion, is many times people confuse sediment controls with erosion controls. Some of you might have been thinking, hey, why didn't he use that, what do you call that stuff, that wattle stuff, that's, it looks like a long hot dog with straw in it. Why didn't you use that? Well, that's because it's not an erosion control, usually. It's usually a sediment control. And so we're going to address that right now. So section 4.3, the very next section in that worksheet, if you're following along, addresses the sediment controls. The first one is temporary silt fence. And we did not select that one. We're going to use something called a compost sock in this case. Now, I'll explain these here in a moment. The next one, SE2 or SE3, sediment basin or trap. And we are going to use that. And I'll show you where, on a very limited basis. In fact, it may even be shovel dug rather than equipment dug. It's not going to be big or fancy, but nonetheless, it'll be a sediment trap. The following one, SE5, temporary fiber rolls or straw wattles. Yes, we are going to use those in a couple limited spots. And when I say grading complete by October 1st, I'm also indicating that's when they're going to be installed. As soon as we're done with grading, we're going to install those devices. Next one, temporary gravel bag berm or sandbag berm. No, we're not going to use that. Street sweeping, yes, but as needed, if needed. We'll watch the street. If we see that we get track out, then we'll sweep it. Now, on a project this size that we're talking probably about the guy out there with a broom. We're not probably talking about, unless they really make a royal mess of it, we're not talking about going and contracting a sweeper on a project this size. Now, a subdivision, yes, they're probably contracting a sweeper to do the whole neighborhood. But here, it's probably just somebody with a broom as needed. Curb cutbacks, nope, not for this project. We'll talk about what that is here in a moment. I'm going to skip drain inlet protection. We'll come back to that. Compost socks, yes, and I'm going to show you why and where we're going to use it and the rationale why we're going to use those. Stabilized construction entrance, yes, but it's not what you would typically think about. It's not that TC1 as we call it many times, you know, with that big rock and the rumble strip that knocks off the mud off the tires. No, obviously a project this size doesn't need it. It's going to be the driveway. That's why we put the driveway in early. That's going to be our construction entrance and exit, and it's really, that's all that's needed. Stabilized roadways, really not applicable in this case. And then stockpile management, yes, in the backyard most likely is where we're going to keep that. So let's take a look at what this will look like on the map. Overlaying it with some of our erosion controls. Notice that right here, I put our fiber roll. The reason I put it here was we didn't have much of a fence there, and flow was generally heading that direction, so we put a fiber roll there just as a good perimeter protection for sediment control. Although the way we graded it, water should flow south from there rather than continuing west, and it should come along the side yard towards the front. Now I'd mentioned that sediment trap. Here's where we indicated putting it. Again, it's going to be just a fat spot in the line. We're just going to dig out a depressed area, maybe just by shovels. It's going to be basically where our any flow that comes off of the backyard that doesn't seep into the ground comes. If one last place for things to settle out. We have a little bit of a fiber roll right here and a compost sock that we'll talk about right here to filter it before it hits the street. So it's just one last fat spot to allow some settling. Stockpile management area here in the backyard. Our existing fence for a portion of this east side, and I may or may not have drawn that far enough down, and then for the back, that's going to be our sediment control. No need to put anything else there. We got an existing fence that's going to stay there. That is a good sediment control. However, down here on the very southeast corner, we're going to put a fiber roll there. Again, because of the flatness of the site, and maybe also to help prevent something that might be coming east to west onto the property and deflect that south so it's not hitting our property, we put some of that here. Our other sediment controls are as I mentioned, it's the driveway itself. That's our stabilized entrance. And then our compost sock I put along the perimeter at the base of the street. Right here, and then a little piece right here. The reason we did that is because that's where water is going to flow off the site, and we're going to filter that water as it leaves the site. We're not trying to impound any water or leave any water on site. It does a good job of filtering. And so let's move on. Now let's talk about some of these sediment control devices. That's where we see a lot of uncertainty about what to use, when to use, how it works. Now, a fiber roll, or straw wattle as it's sometimes called, how does it work? Okay, let's go. A lot of people have some misconceptions. If you notice that the flow actually went up and over the fiber roll. Now, many times if they're not installed correctly, it actually goes underneath the fiber roll. That is definitely not an advantageous situation. Basically, to install fiber roll correctly, it's got to be keyed in so that this 5 to 6 inch diameter fiber roll is keyed in about 1.5 inches to 2 inches into the ground. Then 4 foot on center, you need to stake it in and overlap the ends by at least 6 inches. And the fiber rolls are not filters. A lot of people think they're filters, but they are not. I can prove that through a very high-tech story. 3 little pigs. What did they build their house out of? Straw, right? Why? Because it keeps the rain out. What does much of the third world, many places in the third world, build their homes out of still today? Straw on the roof. Why? Because it doesn't let the rain in. You pack straw into a fiber roll, it's not going to be a great filter. It's going to be more of an impediment device. It basically slows the flow, allows particles to settle out, like you see right there, and that's why it's called a sediment control, is it's not filtering. Now, a compost sock, on the other hand, does filter. The water passes right through, and it also slows the flow and allows a certain amount of settling too. In fact, I got a video here we're going to show about the difference between a fiber roll and a compost sock with an experiment that we did. So let me click that.
For a recent newsletter article, we decided to head out to a nearby gravel lot during a heavy rainstorm to perform some tests with fiber roll and compost filter socks. We wanted to see which sedimentation control device was more effective at removing water turbidity. And as you'll see, the results were actually pretty surprising. First, we staked in the fiber roll around the drain, but we didn't key it in. We did this to replicate an average installation of fiber roll. Now, if you installed the fiber roll correctly, as specified in the Casca and the Caltrans catch sheets, you would probably get much better numbers, but then again, how many times have you been on a job site and seen it installed just like this? We wanted to see how the fiber roll would perform under average installation conditions. We also installed some fiber roll around the drain inlet in a nearby parking lot. So after waiting about 30 minutes for any sediments to settle down from our installation activities, we came back and carefully collected samples from both of the drains and tested them in a calibrated turbidity meter. The results are pretty surprising. The turbidity after the straw water was actually higher than it was before. We didn't perform a scientific test to see what the reason for this was, but we have a pretty good idea. We think the water undermining the incorrectly installed fiber roll was causing turbulence on the other side of the device where we collected our sample. Now, the turbidity in the parking lot installation was negligible. There was, however, a sheen that we noticed, and unfortunately, the fiber roll didn't remove the sheen. We then removed both fiber rolls and installed compost filter socks around both drains. After waiting another 30 minutes, we returned to the drains, and the difference in filtration results was remarkable. The water in the gravel lot was much cleaner, well within NAL limits. The parking lot water was filtered clean as well, and the sheen was completely removed. So, while these results may seem pretty extreme, we actually have documented several projects with results very similar to our experiment. In the weeks since performing this experiment, we've had guys out in the field send us video of fiber roll performing exactly like we saw here in this gravel lot. So it looks like compost filter socks are the way to go for sedimentation control and drain inlet filtration. Fiber roll just can't compete with the efficiency of compost socks. And given the fact that compost socks usually last much longer than fiber roll, the price difference is pretty minimal.
All right. So as you can see, they filter, they slow the flow, and even here, real numbers, 267 NTUs by a turbidity meter outside, 61 inside. Now, let's talk about other perimeter controls, fiber rolls versus curb cutbacks. Fiber roll, as what we mentioned, is it goes up and over. But what is a curb cutback? This is where you got dirt interfacing with existing hardscape, asphalt, concrete, a sidewalk, something like that. And isn't this the same as a fiber roll? In fact, this is one BMP that we tell a lot of people, you know, they don't even recognize it when they see it in the field, or we say, look, you know, this is a good BMP that you don't even have to go out and buy. You just have to grade it in or have the right conditions. And so both a curb cutback and a fiber roll, what do? They slow the flow. It hits an obstacle. On the left, you see that's hitting the fiber roll. On the right, you see it's hitting the curb. But the water doesn't know whether it's concrete or straw. It just knows it got slowed. Particles drop out. They build up. The water continues on. Then it's a great thing. So if you had an existing sidewalk there up front, there would be no reason why you couldn't grade that down, so it's at least 4 inches down, and with your water hitting that, it would slow it, and it would do the exact same thing as fiber roll, probably better, because it wouldn't be undermining the thing and it wouldn't have to be installed correctly. The other thing, when we compare those two to safety, the fiber rolls, what do you got sticking up? You got impalement devices all around. To me, the curb cutback, when it works, I mean, all of these have a safety hazard, but to me, the curb cutback's safer because you don't got somebody tripping over it or impaling themselves. And the reason, I'm going to jump a little further ahead in my talk, but the reason we said compost sock out in front is for installation, ease of installation. Not only great water quality, but I can tell you right now, you go to any average site, what they do with fiber rolls is they sling them out there and say, all right, do your thing. They don't install them, they don't stake them down, they just put them on the perimeter, right? And if they're lucky, they get staked down. But many times if you go take a close look at it, especially if you kick it, it flies up in the air or water's flowing under it. In fact, usually that's where you see the rills is going underneath it. And what our little video showed is actually by the action of that going under there, when it builds up some head here and it undermines that, that's blowing out sediment, it's causing a little jet action, it's creasing turbidity. So your fiber roll is actually doing more damage to the environment than if it wasn't there to start with. And so we're saying use tools that make sense, and let's talk about tools. Now the other thing is I want all the tools still in my toolbox. I don't want anybody to take my fiber rolls away because there are many times they're the best tool to use. One other slide here. Many times there's misconception between fiber roll and silt fence. When do I use them? And we get a lot of questions like that. You know, is it whichever's cheaper? Whichever one's on sale at Home Depot? When do you use them? I mean, aren't they the same? You got to key them both in. You got to, trench them in. They're both getting stakes. One has bigger stakes. But aren't they the same thing? In fact, if we show this, that's how fiber roll's working, and silt fence kind of same thing. But it just builds up more sediment. And really, that's the core difference. When you do your calculations, and if you're a QSD, you're going to learn how to do Russell equations and all sediment prediction equations. If you're getting more than 5 or 6 inches, or actually more than 4 inches of sediment buildup, you probably should steer away from that fiber roll and move more towards a silt fence, which is 3 feet high, and at 50% design, you can get up to 12, 18 inches of sediment and be able to handle it with silt fence. So really, the difference between silt fence and fiber roll, when to use them, is more sediment load. Now, the other time we'll use silt fence is when we want a little bit of wind protection, maybe just a little bit, and also to double as like a ESA boundary to basically delineate our boundary a little bit better, to hopefully protect some vegetation or something like that, or to keep salamanders from crossing over into where salamanders should not go. All right, to demonstrate that it's not about filtering, I took this picture myself on an inspection I did. Chain link fence can actually be a sediment control. Did you know that? Look at this picture here. This was after one storm. In fact, I'll blow it up. Look at the sediment. If you count links, you can see that there's about 3, if not 4, about 3.5 links. How big is a link? About that big. What is that, about 10 inches of sediment buildup behind that fence? Did that fence filter that sediment? No, it didn't filter it, did it? It slowed the flow enough, just enough. I mean, I took that picture myself. Enough to slow it out. So it's not about filtering, it's about slowing the flow. That's what sediment control is about. Now, this sediment was just begging to fall out, and it just needed something like chain link fence to give it an excuse. And certainly much went by that should not have gone by, but nonetheless, that illustrates what we're talking about here. All right, back to sediment control. DI protection, drain inlet protection. Let's pick up on that. And it said within 50 feet. And going to this example we had, the same site. First off, flow's going east to west. And both the DIs are more than 50 feet away. And the only DI we'd be really concerned with is one down gradient, because that's the one that would probably be getting the sediment, but that's more than 50 feet away. So as far as the city's concerned, that's an option. it's probably something you just want to watch and stay on top as far as sweeping, but it would not be required for this. Now, if you're a subdivision under the construction general permit, that's going to be a different story, but for our purposes here, it is optional. All right, now let's go to the last segment here, 4.4, non-stormwater pollutant controls. And the first one, paving, sealing, saw cutting, coring, grinding operations, not a lot of it. Not enough to even mention, so we say not applicable. And S7, potable irrigation, testing, discharge to municipal drainage system, maybe, especially when they're starting to establish their landscaping, possibly some overspray. So I say as needed, it's a possibility. Vehicle and equipment cleaning performed on site, we're going to just say nope, not going to allow it. It's a small enough site they can go to use the coin-op car wash. Vehicle equipment fueling performed on site, we're saying not performed on this site. Now, if you're using gas-powered tools, that's one where you might want to say yes, I got a generator that we're going to be using, or I got a compactor or something that's gas-powered, then yeah, possibly you'd want to mark that one. Maintenance, vehicle and equipment maintenance performed on site, I'm going to say not allowed. We're not going to allow it on site. If something breaks down, we're going to deal with it elsewhere. Concrete, stucco, plaster, tile, or masonry work, yes. And what we're going to do here is self-recycling concrete trucks for the pour, where they're recycling right there using that their onboard vacuum and their bucket that they collected in. And then for smaller work, kiddie pools basically for like the tilers and masonry work, just smaller collection systems that they let dry and then dispose of properly. They'll probably have a porta potty, and so we say yes, secured and contained with the tray that comes with them now. And then storage of hazardous materials such as paint, solvents, things like that. Yeah, initially we'll keep them on the trucks, on the contractor's trucks, and once maybe the garage is built, we'll store it in there while they're painting, especially painting the structure. And so that's how we're dealing with that. All right, now just some notes on the submittal process. So again, this is for the smaller project that is using this worksheet. So this worksheet is going to be part of the submittal, and they'll need to turn this in. But in addition to this, they need to produce the drawings that go with this. And the City of Chico calls this a stormwater mitigation plan, or a SWMP. But there's some other information that needs to make sure it's in either here or also on the map or plans. So property owner name, address, contact information. We saw a lot of that on that first form. The contractor name, address, and contact information, address, parcel size. We had all of that in there as well. But the big thing is a plot plan showing the location of the BMPs with notes. In fact, the building department wants to make sure you got notes on the plan itself. And if you have any questions, you can call Rich Virgie back there, right? And your phone number is right here. And you can talk to him, and he'd give you more information. And here's a form that the city hands out that shows what they want to see on that. And you'll see that at the bottom there's a title page that they want to see. It needs to actually be a part of the plan set that gets submitted. It's not just the back sheet of this or the back copy of this. It needs to actually be a full-size plan that gets submitted with your plans. Now, smaller project, Rich, same thing. Even the small guys turning in the plans.
Right.
Yeah. And so the parcel number needs to also be on there as well. And so much of the other notes you see there showing the elevation and showing the flow patterns and the sediment controls, the erosion controls, all of that we've already discussed. Now, again, it doesn't have to be an AutoCAD document. You know, some of these project proponents are going to be, you know, relatively small entities that don't have those resources. So it could be, you know, using Google Earth. It could be just using Microsoft Word, putting together a site plan, and kind of like we did in the PowerPoint. Okay, so that is how to prepare a small erosion and sediment control plan. Now, they will get reviewed. And so once it gets submitted, the city then does a review of it, and it will be done as the city's permit requires by a qualified SWIP developer, a QSD, or someone working under that. And so they'll use a checklist like this where they'll evaluate it, and then it actually follows a lot of the same BMPs that were in this worksheet. In fact, that's why we did it. It's almost a mirror image where they'll be able to say, did they consider these sediment control devices? Did they consider these erosion control measures? And it'll be, which ones did they consider, which ones did they select, which ones did they not select, and why. And the reason we have to go to that detail is because the city's permit, their MS4 permit, says that in reviewing a project, you have to do this. And so they'll complete a form like that. The back page of that form basically says either it is acceptable or is acceptable with these minor changes, or is not acceptable, and here's the things that need to be addressed. All right.